right, we're live now, and I'm just going to share the link, right? Or share the stream. Let me know the streams. So again, we're looking at Rust, and I'm going to continue from where we left off yesterday. We were looking at iterating over results. Actually, yesterday's stream was on YouTube. I was just trying things out there. That was like the second stream on YouTube. I wanted to see how it was gonna be. Yeah, so but here I'm just gonna like try to go over like quickly what we did yesterday, and then yeah, and then we continue with this, right? So that's it. Yep. So just a second for us to start. Um, yeah. So yeah, Ross, you're taking over results. Second. Yeah. Okay, let's go. All right. So let's do it. Yeah, I have okay, so I have the so again, the goal, I mean for me, what we're doing is we're working on the Rust language, like learning about it, like and stuff. And there's also the Rust links program that we use as an accompaniment. So we learn about chapters, we try out some Rust links programs, and that's how we do it, right? So there is the error handling exercise in the Rust link, and they have this information about further reading that and things that we should sort of like go over, right? To be comfortable with error handling, right? And part of what's recommended is boxing errors, which is in the Rust language reference of the Rust book, and that's what we. So it's basically about error handling. So we decided, okay, fine, let's go over error handling. Even though we already read this in the Rust book, we are now going over it in the Rust language reference. And what we do is we basically also, if we see APIs that maybe like look new or we wonder how they work, we just go to the standard reference for it. So let us get to it now, having said all of that. So iterating over results. Yesterday we're looking at a program, a Rust program that has you have a vector of strings. And by the way, I had like a little bit of cold, so I might be sipping some tea from time to time. Okay, so you have a vector of strings. Um, yeah, and you want to try to convert them to integer. So you want to assume that they contain integer values, and then you try to convert them after getting an iterator, and then you try to convert them. Yeah, but as you see here, because we have this is a string literal, it's also a literal, but it can be converted to an integer um, value here. This will fail, this two will succeed, right? When you try to parse the value to a 932, you would have a passing error, right, for this. Now, iterating over results, what we saw yesterday is that you first of all can ignore the failed items, right? So basically, pass returns you a result, and you can um, you can decide that you want to ignore the ones that failed. We can do that with filter map. So let's go over that again and see how that's done. I have a program here for error handling. I think I would just, I think I wrote the program yesterday or so. I don't know, but let's get rid of stuff and like go over it again. Like let's write this code and so just practice like let's see how that works. Yeah. So basically, we have just the main function for us, right? Yeah, I'll have the main function. Don't mind the fact that the main function here returns result, unit type, and boxed in error. It can also be like this, right? It can also be the regular main return unit type, right? This would also work. But this is also another way to do it, right? So this is also another way this would work, no issues, yeah. So they're both the same, right? Your main function can also return a result, unit type, or generic error, or like boxing error. Okay, so I just wanted to get out say that, make that point. So now we can write our function here. What do we want to do? We want to get if so. Let's say we want to. The goal is to iterate over a vector of strings. I hope this is even clear. Yeah, okay, legible. Please. A vector of strings. Convert the values to integer values, right? To integer values. Ignoring errors, yeah, ignoring errors as well, ignoring errors or failures, right? So that's it. We only want the cases where it succeeds. So how do we do that? And by the way, this is written okay unit type because result, right? So we have to return that. So that's what it is here. We learned about this earlier. So what do we want to do? So that's the very similar to the example. We can say let strings be a vector. So we use a string macro to initialize a vector and say like tofu, and then like I don't know 98 and 100, yeah. And then we want to iterate over this vector. One way we can do that is, I mean, if you want to use the collection API um, to do that, like, or rather, you want to use the iterator API. Actually, I should say that's what it's called here. It's not Java. It's not Java where you use collection, so it's Rust. Yeah. So if you want to use the iterator API for this, you can actually do a for, right? Item in strings. Yeah, you can do this. However, um, this would this would work via side effects, right? But you can also use an iterator to chain it, and that's what we want to do. So we can say strings dot. We can say iter gives us an iterator already, right? So we can also do into iter. What would be the difference, right? Into iter, no, no, not into iter mode. I mean into iter. I think it's like into iter, I guess, right? Yeah, into iter. Creates an iterator from a value. So what if I do iter? Returns an iterator over the slice. Uh, yeah. Mm, wait. Creates an iterator from a value, and the other one is going to return an iterator over the slice. Okay. Okay. Uh, Pardon me. I'm just windy here, taking my tea, but. So let's go with into iter because we want to create an iterator from the values from the values here. So we get an iterator. This gives us an iterator. You can see that by saying let value be this, right? So we get an iterator, use an into iter, and then we can say so we can have an iterator. Now we can go over the values, right? So we can do a map. We can do a map and say like I, for example, like so for yeah, so to yeah, and then we can say I don't because it's a string. It's a reference to string, a string slice. We can try to parse this and say like it should be I32. Um, so we try to parse this, and as you see, look, observe. We what we get now is like what we have now is a result, right? A result type. And by the way, let me see. Yeah, so we try to parse this. Nice. Okay. Yeah, so we do into it there, and then we try to we map the values, right? So we map values of values here, and then we try to parse this. This would give us a result type already. This gives us a result type. And then we what we said is we want to be able to. And by the way, why is this? This is like result of what error types. It's not saying. mm, the type of this type. We should be having um wait. I think we need to because it's we tell this is an implementation of an iterator that is this. I think I and by the way, I think map is what's the STD? I think map is lazy, right? So if I go to iterator now, iterator trait, and we go to map has to be lazy. Takes a closure that calls uh take a closure. So basically it transforms one iterator to another area by into the argument, produces a new iterator which calls closure on each element of the original iterator. Yeah, map is considerably similar to a for loop, however, map is lazy. Exactly. So map is lazy. So we don't get anything from here yet, right? So I guess that's why we don't have a results type returned yet. Because it just yeah, so that's it, that's the reason. So we would need to collect this, right? So basically we would um we need to collect this. So anyway, let's not derail from that. Once you treat it as a vector, I convert the values to integers, again, ignoring that, right? Um, yeah, I think we can say so. Yeah, we do that. Um, one way we can do this is also to say like this is going to be an. I think yeah, this we can say this is the vector of I32 type. Yeah, yeah. What it needs a semicolon, yeah. Okay. What is this? What do you have? Vector identity can be built from an iterator. Why can't you do that? Why? Because map is going to method may not have the expected associated types. What does the map return? Right. So this is a string value. I can parse this. What does the map return? It's the closure. It's just a closure. Um, so if you have an iterator that gives you elements of some type A, you want an iterator that gives you elements of some type B. So it only maps the types, right? It only maps the um yeah from string to integer, right? That to I32 types. That is it. There's nothing else that needs to happen here. So but then what is the problem? We have map. You try to collect it, and I'm saying give me actually a vector of this type. Is that a problem? Cannot be built from an iterator. Okay, so let me see. I'm just gonna say collect. Now type annotations do not satisfy this. So the problem is that what type annotations needed. So type annotation needed. It needs to know what the type. It needs to know how to collect the. It needs to know how to collect these values. It doesn't know what to do there. So we need to provide. We need to help this by saying this is a vector of I32, right? And then now what? Now what is the next error? Now you say that, so now I helped you by providing the type for you, and now you say value of type vector item cannot be built um from from So what you have is an iterator that is a result of I32 and passing error. Okay, so I think what we need is, um, so it says that help the traits from iterator, this is not implemented. So we are not able to get uh, of vec32. Okay, from vec I32. I think what's going on here is that this is a result, but we are saying this is going to be this is a result I32. Okay, I think that's the issue here. So this is actually not vec32, but this is actually a result of type I32 and passing error. Yes, that's what it is. That's what it is. Is it not? What is it? Hmm, let me see. So value of items is gonna be built from. So I'm not gonna give this a type here. I'm just gonna say this. I think I need to let's figure out what's going on here. So we have a string. We get an iterator. We map this and say convert this, and we say collect. So what is the issue? Um, After we map, okay, let's walk this through. After we map this, I mean we map this. This would give us a result. I mean at this point we would get a result. Oh, I32 and yeah, result I32 and fastened error, right? Or that's okay. That's what we would get from here. And then if I say uh, okay, I try to get the okay value of this, then what? Then I don't know, I'll say parsed, yeah. It's only parsed. Okay, so if I say so yeah, okay would convert, yeah, actually. So okay converts the so I map this, I get a result type, and then I convert this to I convert this. So if I do that, okay, I'm going to convert the result type into an option, yeah. And then if I collect it at this point, what do we get? Yeah, if we collect it at this point, um, type must be known at this point. So if I collect, that is um, that is going to be the okay is actually an option at that point. So I'm gonna try to do this again. This would still be a vector. The values that will be there are actually okay, right? I32, right? It says it is an option type. That's what I expect, but the same. What is the syntax error? Blah blah blah. What is? Why do you? What do you expect? Expected argument list. I think it's a syntax error. It's a syntax that has the issue there. So basically, we want to collect vector okay values. How do you do that here? When you say collect, let's see. When you have collect on an iterator, yeah, we are on iterator. Let's try to let's do collect. Let's see. How do you collect stuff here? You can use the table switch operator to collect, like so. This is what I'm trying to do here. And then what? Is there an example of how to collect this? This is exactly what we're doing, yeah. Oh, wait, is it? Oh, that is not correct. That is going to be, oh wait, hold on. Let me just move things around a bit so you can have it like so. And that's what we have actually. It's like, okay, wait, maybe it's because we have, wait, let's see, let's try this out and see. Uh, oh, wait. So a value cannot be built from an iterator. Come on, what's okay, so I think I want I want to read about this and let's figure the issue. Uh, it's part of practicing how this works, right? So um what is what's the big deal here? It's like a vector of strings. This expression has type. Okay, this expression has type vector that has reference to string slice, and then we do into iter. Iteration item here is reference to string slice, and then iterated item change to result. Exactly, that's what we do here. This changes to result type. I32 here. We do a map that okay, and then iterator item is changed to an option of I32 here. So this is we're gonna have option of I32. So this should not be like so. Like what we had before should be correct. Now, not required by bound in collect. So it just says that cannot be built from an iterator item option. What if we, so are you saying that we need an option? Why can't I use OKs directly? Like why do I need to have it like so? And now it says expected argument list. Expected one of bang or this or that. Is that in the wrong place? It's not. It's not. Wait, what sorcery is this? Is this not what we're doing here? Wait, let's write this. Let's write something fresh, right? So let's write this again. So let's say, okay, so what? Let's say we have let A be vector. of 1, 2, 3, 5. And let's then do a dot uh, iterator dot map. We take each item here, which is an I32 value, and say I times 5, and then we have this, yeah. So you say let result be that, yeah. So you see, it's an iterator that has that where item is I32. It's lazy, I guess. So let's now collect this. Let's collect this. It will tell us it doesn't know about the type. Yeah, type annotations are missing. So if I say that this is going to be this is also a vector of I32, are you able to now collect it? Yes, you're able to collect it. So if I then try to run this, oh wait, I should print result actually. So let's say we want to print result is result, yeah. So we can run this. Oh wait, what? Uh does not implement display. Oh yes, I get it. You need to be able to um yeah. So now we just use the map um to print out the to perform. So in the closure of the map, right, we have a function or whatever there, a function that does something, and on each value there, and then we collect it into a result. This is what we wanted to do here, and this is exactly what we wanted to do here. So same way, if I had this as strings, I could also do the same. Yeah, come on. Yeah, I could say I have this as strings now, and then I can say so. This would be I'm trying to so now we cannot just map it, right? So we have to in this case we would have to say we have strings. We make it into get an iterator. We can try to map this, and then we can say for each string value here we want to say parse it or parse, yeah, sorry, parse, and then we make it I32 type, and then um yeah. So first of all, I think I'm gonna get rid of this first, right? Let's say this is gone first of all. So if I try to collect this, yeah, hold on, I don't want that. So yeah, so at this point, right, everything is a so each item here is a result type. That's the thing. So it's now we're trying to do a parsing on this one. So so it's a result. Now what do we need? We need to we want to collect the values, right? That get um so we want to still do what we did before, right? Like on each item we want to multiply the ones that succeed, right? So we need to find a way to um we need to do a map again, right? So we can do a map again and say that map, yeah. And then on that remember is a result, yeah. So let's say it's still S, or maybe I call it A, right? So and A dot uh actually no, we can actually do a filter and say, well, it's okay, yeah. That can work. That we can do that. I guess we can do a filter. Did I use yeah filter and say like where is okay, yeah, and mhm. And now we can, now that we've done a filter, we can do a map. So wait, like I guess that's not what I want. I want to, I mean, it's when we do a filter, it's just going to, I think we don't even need a filter there, right? Because we can actually just do a map. We can do a map and do the filtering right there, right? Or maybe just because we want to chain it, then maybe we can say, okay, let's just do that, right? But because even filter right now, filter is giving us a still a result, you know? So I don't really want to do that. I just want to do a map instead and say, I'm still gonna say S, yeah. And then inside of here, I should say uh we can do a we can do a we can do a filter. Wait, we can do it's we can do s dot wait. So let's say we do a basic map and we want to map this a to an option maybe, right? So we say s dot okay. This is gonna convert this to an option already, right? So this is an option at this point. Mhm. And then what? Um, and then I can collect. If I collect this, actually this can even be a filter map. I know this can be a filter map because filter map will do a filter and a map, right? So it will do a filter where S is okay. I mean, when values are some values, that's what would happen, and and we can now say why can I collect this in here at this point? So you need annotations. You need annotations here. One moment. One moment, please. Okay, so the issue, I think the issue here is just about the type annotations here. Because like we have a filter map. This is going to be, it's going to contain OK values at this point. Um, yeah, only the ones that succeeded. So now, um, actually, do we want to collect because we only have, so filter map is going to give us just the values that the filter map takes us as a result of I32 and passing, and then only where S is OK. Begin that you see what Huguenot does. Yeah. In this example, we still, so for example, in this example here, we will still need to, if we want to, I mean, it's the collecting that is probably a bit clear here. Expect to be able to just do a collect, right? So this example, they provide the type it collects into after they do that, and that's also what we did. Um, so this is a vector of I32 type. Why is it not? Yeah, it is. Yep. Okay. Okay. So it's a vector I32. So why flat map would, I mean, sorry, filter map. I call it flat map. Also, that's that Java has a flat map on the collector interface. Yeah. So you have like a result, and then you would do the filtering where the value is okay. Yes, and it would map it to the value that you have there. Yeah, that's what it would do. Map it to the value that you have there. So why not? Um, so basically, if we have like something here, I think it's the same example anyway. If we have like tofu here and sardine here, for example. Wait, I did not put a comma here. We have these, we would there'll be no problem, right? We're still fine. They got rid of them. Yeah, so that's what we wanted to do. So exactly, we try to write vector of strings and we ignore the errors. Yeah, so that's what we're doing. We're just ignoring the errors. We only have the ones that succeed. Um, we can also even like process this, right? So we can say after you parse this, filter the ones that are okay. And can I want to do a map, right? So I want to map each of the items here now and say I times 5 like we were doing before, right? So yeah, that would now work for us. Yeah, so that's fine. Okay, so I think that's the same example we're trying to do here, but I don't know. Okay, so yeah, we were going the wrong way earlier. We were going the wrong way. We were doing what we're doing here. We're doing map. Okay. Um, yes. So I think so. I want to do the same thing with if so we use a filter map here. And look, I have like map, filter map, and map. Why can't this be shorter, right? Why do I have to? Why does this need to be this way? I want to get um. Why do I have to do? So first, I get an iterator. I map this, convert this, I do a filter map. Say like it's okay, and I do a map. Three. I chain it 3 times. Why? Why can't I do all of that in one um place? Yeah, I can. I should be able to do that in a map. Why not? So basically, I can do a map, and in the map, I can do a filter, and yeah, let's try that in the map, right? So I'm gonna leave this as is here, just for reference here. Um, so now let's come back to this example we had before. So we had a map, and then we say filter map, yeah, and this is a so this is a that yeah, by the way, we didn't even try it. Okay, so we didn't collect, we're collecting now our vector I32. So I think this one, Yeah, exactly. This should work, right? Why it says that. Oh, wait. No, hold on. Um, okay. Yeah. So this would work. So we have parsed now. It's the same thing actually. Like this would, in this case, like print line result, and here I would say parse. Yeah. So it just ignores the errors, right? So this is what we have here. This would work. So two ways, right? So we can use the collect and terrific operator without putting the type here, and then in this case we put this here, and the compiler knows how to do that, right? But I was saying that so we did a map. So here we did a map and filter. So we didn't need to do it like I don't know parse and filter map and this here. Here we just did a map, parse this, and we filter. Yeah, that's true. And here we are not we're not getting we're not multiplying this by a factor like we were trying to do previously. Yeah. So if we wanted to do that, how would we do that here? Again, filter map takes presenting of both filters and maps. So yeah, both filters and maps. So basically we can get rid of this. Um, and if it's if it's both filters and maps, then it means we can say s, we can string, and then we can say s dot parse y32, and that returns us a result. And then we just do that okay. So you say the ones that are okay. Yeah, that'll be fine. Okay, so we got rid of one of that. And then what about when we want to um do a factor of that, like we want to multiply this, yeah. I think we can do it like so. So let's say, so I'm gonna do this. I think I use a filter mark for it only. Or we don't need anything else. So I'm gonna say that I'm gonna do a parse here. Or rather, I'm gonna do a match. Let's do a match here. I'm gonna match to the value, the return value of the parse. So I32. And after the when we match, even though match is like a bit verbose. Okay, but anyway, when we match this, we can say it's if the variant is if it's an okay with the result, which is I here, I want to do an I times 5. If it's an error, whatever kind, mm, okay, yeah, I will just write this. I'll finish writing this. It's an error. I want to ignore it. How do you ignore it again? I think it's like this, right? Oh, wait, how do I say I don't want to do? Okay, wait. Is it the unit type? Wait, hold on. Um, okay, yeah, that's true. And so basically this needs to return an option, right? Because filter map, it needs to return the values where there's some. Oh yeah, that's actually correct. So I don't need to return unit type here. I can just say none here, and here I can say if it's okay, give me okay of give me wait, come on. What's that? No. Yeah. Yeah, I can say give me okay of um items five, right? Mm, sorry, not okay. It's an option, it's some. Yep. So that would be correct. That would be correct. Yep. Now it does five times those things. Okay, so this is also using just a filter map for this. However, match is not very match is not very, as you can see, I mean we you know, as you can see, we're not doing anything here with error. So we can even actually replace this with, instead of doing a match here, this can be done with an if let, right? Because this is not doing anything, error is not doing anything here. So we can actually say if let um v, yeah, so because so sorry, if let some, yeah, if let some, no, so wait, that was the result, yes. And what we want is that if the result is okay, that's what we want. Is the okay one we want, not some, yeah. So if it's an okay value of something, which is I here, I will study I. If let s dot parse the structures into that, so you just get rid of this now. Say so if this right hand side is able to be destructured into OK and I, then I want to return um I want to return a sum I times 5. And this I don't need, and this I also don't need. Because there's no come on, why do you but wait, I don't need an else here. I only want the sum value, right? So missing an else clause. Oh man, come on. I thought I could. Okay, I was expecting. So basically, you're saying that I should provide you an else and say else, um, else none. Would you be? Okay, wait. This is just very stupid. Like, come on. Okay. I mean, I was looking for like a simpler way to do this, without having to do like sum and none. I don't like this. So it's more readable when you do it the other way. It's more readable when you do dot um dot map, and then you say s s dot parse. So just convert this into a string, into okay or parsing error or whatever. After you do that, then you change it and say and say filter map is what you want to do, and then say that the value you got from there, which is s now, which is the result or that, then you want to say um wait, actually no, I think what we want instead is to do a filter map and then do a map afterwards, right? But why can't we say, hold on, I think there's another way. Hold on. I think we can do, so we have filter map, and when we get the value, the return of this is a result. And result implements the iterate. No, wait, hold on. Result, trade, results, enum. The traits it implements, does it implement iterator? I mean, we it has some methods that we can use. So we have the standard iterator methods on it that are implemented. We can even get an iterator actually, yes. So exactly. Mm, but that's not what we want to do. We want to say, uh, yeah, I don't want to return a result of a result anyway, or boxing that into something. I'm just thinking anyway. I'm just here thinking about how make it a bit less verbose. Just yeah. Okay. So, but anyway, um, we know how that goes. We know what. Let's move on. I don't want to spend too much time on that. We already got it to work, so that's fine. I just say that we would do a filter map, and then it would be s or what value it is, plus yeah, and then that this is okay, right? So if this is okay, then this would automatically be converted, right, to only the values that are so that succeeding being converted, this and this. And what we want here, I have this feeling that we can do this here actually. I see it here, we can do it. This gives us a result, and I want to map the result. This is a result, and I want to, okay, actually, it has to be the ones that are okay. Then I take those values, and I take the value that's in the okay, and I, what is actually okay does the conversion. Yeah, okay converts the result to an option. That's what we've done. So I have an option of the of the converted value. What can I do with that? I can do and then on it. Yep. So an option, I can do and I can do so and then does it takes a closure. So it returns none if the option is none, otherwise, yeah. Calls f with a wrapped value. Right as a result. Example usage is like you have some do and then do something. Yeah, I can do that. I can do and then I can say each value here, which is now an I32. I can now say this times 5. Why would this not work? What does and then return? It also returns an option. It returns none if the option is none, otherwise it will do that. So why not? This match types expected and an option. What did you find? Um, and then UF takes this, got a flat map in some languages. Yeah, this is a flat map in some languages. This should be fine. What's wrong with it? I want to see what's wrong actually. Or why this would not work. Expected enum. Right. This might type. But, so it's here. Expected option of whatever type found I32. Okay. Is it because of the and then? Oh wait, that's true. So because like um okay, yeah, this is supposed so this is so this starts with an option and then this would take the value in the option and do something with it and return an option of a different type. That's what it's doing. So what's the big deal here? It's exactly what I want to do. So if we put this in in a sum, would that work? I guess that would work, right? So and then I see the issue. Is it wait, I see. Okay, this is returning this has to return a sum. Sorry, an option. So this is return an option in this case. That's why it works. So you're telling me that I need to return a sum here for this to work. Is that what you're saying? I'm missing some closing parentheses here, right? What am I missing? Syntax error. What's the missing thing here? I think I have a broken delimiter. So this is like okay, and then this is for this. Probably need another one, right? Okay, I think that works. Yeah, it does work. And that's the fun part of like these kind of sessions, right? We would, I mean, I'll just, I just try what I need to try out. That's it. Um, but anyway, the thing is, I wanted this to be like do that in one line. I didn't want to do that in one, two, three. Even though it looks like okay, fine, you see what you're doing clearly, but at least I felt like we could just. And by the way, I don't like how this is supposed to. I expect this to wrap around or something like maybe like this, maybe like this. No, not like this actually. So like here and then, in fact, like why not like so? Yeah, why not like so? This is how I would want it to be. So exactly, this is how I want it to be. So it says using option and then, which is wait, using option and then, which is substantially more expressed as. I think Clippy wants to tell us like something we should do better. Let's see. Um, I don't have that one. That's Clippy warning is not here. I'm gonna have to like minimize this a bit so we can see it. Sorry. We should do what instead. It tells us, so it gives us like suggestion. It says bind instead of map. So it's checking for unit of and then some. Okay. It says bad because it can write it more concisely as as something else, right? So we can do the map. Well, what we are doing is, and then x sum that. Okay, it says we can write it more concisely as dot map or the map error. So I think I get what's saying here, which makes sense too. So it's like, and then s, and then you're doing sum this. So you can just do map. Is that what we're really doing there, actually? I mean, now that I mean, you probably need to look at the code later on to tell, but it's like you have the OK value. I mean, you convert that to an option. Yeah, you can just do a map. You don't need to do and then this, right? Just because that makes sense actually. So you can say that map uh, I think if we do it like so, then that would be fine. We don't even, yeah, that's true, actually. Yep, even better. So even better. Yeah, yeah. So, I wrote this yesterday, but I wanted to go over it like to, so when you see the reason why it's needed or why what you can do, I think it sticks better. So that this makes sense. So this makes sense that you can just do the flat map, and then inside of it, you can, when you have the option, you can work on the option. So you can basically do a map on the option because this is already a sum. So this would give you, of course, the option. I mean, flat filter map would do a map and a filter. Basically, to only give you to only give you the cases where you have some values. So it has to return like an option, but only some values will be present, right? Only the ones that have some will be present there. So we already convert this at this point to an option, and then we can just process it. This is really cool. Now, the other thing we were looking at yesterday, I should get rid of this. So I think we're fine now, right? So this is okay for us. Um, the other thing we're looking at yesterday is like, um, so how do we deal with these side effects or like the errors, right? So let's say there are errors. Let's say there are errors that, okay, like the parsing errors we talked about now, right? How do we um, how do we get the parsing error to how do we get the parsing? So what if we wanted to collect the errors, right? So let's say I want to collect the errors. We can actually do I collect errors, and we can say this is an empty vector, yeah, with unknown types, right? So let's say it's the vector of unknown types. It says type annotation needed. Again, like this is fine at this point. The compiler is just complaining because it doesn't know what type to put there. We can actually tell it that this is going to be, um, we can actually say that this is going to be a vector that contains parse int errors. And yeah, we can say this, right? And and we initialize this to an empty vector, right? That we can do, right? We can then say that when we have an error, we want to collect the errors into that vector, right? So that side effect. By the way, for us to be able to iterate to mutate this vector, it needs to be mutable. So we would need to say this is a mutable vector. Yeah, it says it doesn't be mutable because we haven't yet started to put things into it. That's fine. So how do we do that? So at this point, we do the past. Um, so we convert this to an option at this point, and the option would be a sum of that, right? So um, how can we collect this? If we take the example that this was showing us here, No, this would not work because I mean, filter map. So by the time we already do this here, we have a result. We have a result here. I mean, here we have a result. We can actually call a map here at this point, like before we call OK, right? So I guess we can do something. So yeah, we have a result passing result of iterator and pass iter here. I guess we can do a map. So let's say we do a map error here, and we say um we can do a map error here, and we want the error to. So let's say we have like um I don't know, error maybe, yeah. The map error will just convert the error to whatever to what we want, or do what we want with the. It will actually, so map error will transform T and E, right, to like T and whatever else. That's it. So map error will act on the error, leaving the actual value untouched, right? So we have a result that has I32 at a passing error. When we finish executing map error, we would still have the values in the OK variant. It's just that the error is what we're going to act on here. So that's what's going to happen. So we're processing the error, and then we'll say, and what we want to do here is that we want to do errors dot push, and let's push the arrow there. And now we can further, so now we can further process this at this point. So first of all, let me get rid of this. So we have like a map error here. We push this to this. Yeah, so after doing the push, as you can see, what we have here is result I32 and unit type, because we don't return any errors. Like we don't transform the error, so that's fine. We still have our result of that type, and here we can then do a we need to convert this result to an option, right? So we can do OK. So now we have option I32. It's still inside the filter map at this point. And here is where we can then do a, I mean, do we even need to do an OK here? Why can't we just do a map? Because we already have a result I32. So I can say val, yeah. And then I can say that this should be a sum. I mean, this can actually be I, not val, even I. And this can be a sum of, no, it's sum of I times 5. Why not? What's wrong here? Okay, I think I need to do this, right? What is the issue? Is it, do I not have enough? Oh wait, this is a, okay, yeah, so yeah, mapping it is gonna be a result of option. Ah, okay, so okay. So map will not work here. So basically, again, because this is going to return us a result, that's it. Okay. Okay, so wait, let's, so rather we map the error. We need to convert we need to get the result. So wait, hold on. I was trying to make it so we have a result, I32. We need to we need to convert this to an option, because like first of all, filter map would be, it needs to return an option. So we can say we can return dot OK, right? From After doing the map, we have that. We can why don't we do okay? But okay would be wait, hold on. Let me see. What do we dot hmm. We can do dot okay. So just convert it to a result. That's it. Ah, wait. I think what we had was okay, was fine. Why not? Why not? Why is this not okay? So why we can do what if we do dot okay here? Oh wait, option. Ha ha ha. Oh yeah, we don't need this then, so that's fine. We can simply say, don't give me this. I don't need this anymore. And I say that okay. Syntax error. What is we're missing something, yeah? Expected right parenthesis. Where is that missing from? This is fine. This is not fine. So I think it's here. Yep, that's it. That is it. Okay, so that's it. We are able to collect this. We have the arrows here. So inside of, I love this. So inside of the filter map, I usually call it flat map. Oh, come on. It's not a flat map. So inside of filter map, we can do the processing here. We parse the values, we map the error. Well, I mean, mapping the error just gets the error out of the way, and we continue to process. We do a map, and we don't okay. Yeah. Okay. So and then when we're done here, we simply convert this to an option because that's what we need here. And then we collect it into a vector of our type, and that is fine for us. So we can print result and print errors, right? So let's say print line errors, errors. That's fine for us. We can then. Oh, what is it? What did we? What's the problem? Okay, yeah, I was wondering that we were missing something here, right? Yeah, exactly. Um, okay. Yep. So we have that. We have these two values that are multiplied by five, and we have the error, right? That's the parsing error. However, I'm not quite satisfied with this because so if I do this, I think we're not gonna move on. I need to move on to other things, right? So like, yeah, we do. I mean, I think we've seen iterating over error. We've seen the filter map. We even use it in our own example, like we use it in our own way. I think that's fine. We also did collecting the field items with map error and filter map, which is fine. I mean, we so look, they did a map and they did a filter map. They did a map and they did a filter map and they did a call map error inside. For us, we're doing essentially this, but we're doing it inside of filter map, which is still fine. Which is I like this. But I mean, this is probably maybe more readable, right? So you do a pass first, and then you do the filter map inside. It's okay. Yeah, maybe you pass it first, and then you handle the errors here. Yeah, also okay. Yeah, but as you can see, like they still call that dot okay in the end. Yeah, so I think it's the same thing. And they say fail the entire operation we collect. I think this is what we did not see. So, but I also don't like the fact that even though you have the errors, you do not know which operation you try to process that caused the error. And I would like to know that. Basically, I'm saying that I want to instead have a hash map. So the error should be a hash map, not just this. So the error should be there should be a hash map. Excuse me. So let's say I have a trying to remember the syntax for hash map now. Right. Um so let's say errors. Sorry, I'm just gonna get rid of this vector now. Oh no, I can actually collect the vector into I can collect it as a hash map. But anyway, let's yeah, but that's fine. Let's just make it a hash map directly. So errors equals of type hash map of I32 and error. I think I can use error, right? Well, we know that it's always going to be a parsing error. So what's the we can use a parsing error, or maybe I can use error. Maybe I think parsing error also implements error, so we should be okay. Let's try this. Hash map new. Yeah, the size of maybe this can be a wait. Can I do a box in error? Okay, that works. This is if I want to do this, right? So now what I can do is I can push uh I need to push key and a value here. I no no, it's not push. I think it's wait, hold on. If I want to get values into a hash map, what do you use? Is it push? No, it's not push, right? Errors that I don't remember. I don't actually don't remember what you do to for a hash map. This is why I want to try it, right? So I can recall. I mean, let's try. Let's check it out. So hash map, it's insert. Yep, that's it. You insert, and then you insert the key and the value. Yep. So the key here would be um. hmm, Okay, that's true. Do we even have this here actually? No, we don't have. Oh wait, this processes the map error will process the error actually. We don't have the oh interesting. We don't have the value. I mean wait. Map error. Let's see map error again. Hold on. I want to see. I think that was on result, yeah. Yeah. Hmm. Marks the result here, the results. Applying a function to the content error. Yeah, we can do that here actually. Okay. Okay, that's something I would want to do. Maybe I guess we'll check how to do that later. So I'm not able to see that. That is, hmm. But what if I did? Yeah, we don't have access to that. Okay. But if we have it, okay. Yeah, we can actually we have access to it, right? Because no, we don't because this is I think we have it. We have it because that's one of the benefits of doing it like so because now we have the value we're acting on, which is the string the string here. So we can actually say the key what the hash our hash map is like I32, no, it should be string because can I just do this? Yep. So now we can say this would be a um S. You can pass S like that, yeah. And then the value, that's the key, right? And then the error now should be error, right? So why not? Doo-doo-doo. Doesn't work. Closing delimiter, it's a delimiter problem. I don't like the fact that we even have this delimiter error. And so, okay, so now tell me what the type problem is, because that is supposed to be a boxed in error, and we are just putting an error there. So we need to say box new, I guess, error. Does this do it? So what is, yeah, come on. Okay, yeah, this would be fine. I mean, I think let's try. Yep. So now we're able to see what caused the error. I mean, what we tried to convert that caused the error. It was tofu, and we cannot convert because you got a parsing error and the kind is invalid digits. All right, this is a good place to leave it. Um, yeah. Okay. I'm gonna when I continue with the stream, maybe I think the next stream is gonna be my next stream is tomorrow actually. So we'll continue with collecting the field items with map error and filter map. No, we do this. Failing the entire operation with collect. This is what we'll continue with, right? So yeah, then see you later. Bye.